from number 4, A, B, C, D, E, and F. And each one of these has different units to begin with. Your data is different units. You're either starting with atoms or you're starting with molecules. But at your end result is to figure out what is the mass. And remember, mass will be in grams unless stated otherwise. What is the mass in grams of each of the following? So make sure that you have a periodic table out in front of you, and then your general relationship set up for introduction to stoichiometry. And you can see that I have that written up at the top in blue. So let's go ahead and start with question number 1, 4A. So I'm going to start with my data, and my data is 3.011 times 10 to the 23rd, and I'm starting with atoms. And it's atoms because I'm dealing with an individual element, just fluorine. And I'm trying to go from atoms to grams. So what's happening here is that I'm at this unit right here, and I'm trying to get to this unit. So what I want to do is I want to look at the relationship between those two. And their relationship is right there. So I'm going to take that relationship, 6.022 times 10 to the 23rd atoms equals the number of grams from the periodic table. And when I set that up, I want to make sure that I set it up so that my conversions, my units cancel my conversions. So I'm going to start with atoms in the denominator. So I'm going to say 6.022 times 10 to the 23rd atoms in the denominator, and in my numerator I need grams. I'm specifically dealing with grams of fluorine. So this is now where I go to my periodic table, and my periodic table tells me that fluorine has an atomic mass of 18.998. So now watch your units. Atoms of fluorine, atoms of fluorine. The unit that you're left with is grams of fluorine. There is another option to this. You could have taken a longer route, which is completely acceptable. In fact, this would be the only time that you would use this, would just be introduction to stoichiometry. As soon as we transition into actual stoichiometry, you're going to want to make sure that you're always using moles as part of your conversion factor. So let me show you what that would look like with the next question. The next question is also going from atoms to mass in grams, but I'll show you the longer route, and really the one that I would encourage you to focus on for our chemistry class. So I'm going to start with my data, and my data again is 25 atoms of tungsten. So you're sitting and looking at 25 atoms of tungsten. They're pretty small. You want to figure out what is your mass in grams. So let me take the longer route. Notice that again, I'm starting with atoms, and I want to end up with grams. But I can also focus on the relationship between atoms to moles, and then focus on the relationship between moles to grams. And remember, moles to grams or grams to moles, this conversion factor is really important. That's called molar mass. So I'm going to use two conversion factors to solve this problem. A and B are exactly the same questions. I'm going through a longer route to solve B to show you how all these conversion factors relate to each other. So back to my data, 25 atoms of tungsten. I want to first go from atoms to moles. So I'm going to set this up so that I have atoms in my denominator, moles in my numerator. Next to atoms, I only have one option, 6.022 times 10 to the 23rd. Next to moles, I only have one option, 1. Never put down another number for moles for a conversion factor. Now that I just got rid of atoms and I'm in moles, now I can go from moles to grams using molar mass. So what I'm doing is I'm going to look at the relationship between this to that. So when I set this up, I'm going to set it up so moles cancel. So that means I'm going to write 1 mole in my denominator. Next to moles will always be 1 in a conversion factor, never another value for molar mass. And then what I want my numerator to be is I want it to be grams. So this is now where I need to go to my periodic table and find tungsten. It's number 74. And my atomic mass is 183.84. And the unit there is grams. So now going back to my units, moles and moles cancel, and I'm left with grams. Remember in your calculator, whenever you have a 1 in the numerator means multiplication, the denominator means division. So if you have a 1, you can skip it. So if you were to go to your calculator, you would say 25 divided by, because it's in the denominator, divided by, and make sure you do open parentheses, 6.022 times 10 to the 23rd, close parentheses, and then times 183.84. Looking back at question A, you had a value in both the numerator and the denominator. So what you would need to do here is then open parentheses, 3.011 times 10 to the 23rd, and then times 18.998, and then divided by, open parentheses, 6.022 times 10 to the 23rd, close parentheses. So just remember to use your shortcuts. If it's times 1, skip it, divided by 1, skip it. Your fraction is always going to represent multiplication in the numerator, division in the denominator. This is for your conversion factors. Try to focus on practicing this format, going from atoms to moles, moles to grams. That's going to be a better set to study and to practice, leaving introduction to stoichiometry and going into stoichiometry.